In this session, I am going to explain about the transmission parameters. Transmission parameters. So, as I already discussed about the two-port network, this two-port network can be represented with a rectangular box with 4 terminals like this: V1, I1, and it is a two-port network. This current is I2 and this is the voltage V2. It is 1 dash port 1, 2 dash this port 2. Among these 4 variables V1 I1, V2 I2, 2 variables can be represented in terms of remaining 2 variables. So here in this transmission parameters, these 2 variables, input variables V1 I1, can be represented in terms of V2 and I2. That means this V1 comma I1, these are the functions of this V2 comma minus I2. It is not plus I2, it is minus I2. This minus sign is because of the actual direction of the current is from left to right, but the conventional direction of the two-port network current direction here is from right to left. So I need to take this negative sign for this current here. Actually it will act as a source and it will act as a load, and it is a transmission line if you consider this transmission parameters. So the current will passes from source to load. That means the current will go and this current will go to the load in this direction, but the conventional direction of the current will be shown from right to left, but the actual direction of the current is from left to right. That is the reason why I am taking here the negative sign while representing this V1 and I1 in terms of V2 and minus I2. Now in a vector matrix form, this V1 I1 can be represented is A, B, C, D. It is V2 and it is minus I2. Now if I write this equation in a equation form, that is V1 is equal to AV2 minus BI2 and I1 is equal to CV2 minus DI2. These A, B, C, D, these are the transmission parameters or ABCD parameters. How to find these ABCD parameters or transmission parameters? First thing, if port 2 is open circuited, then what happens? That is, if port 2 is open circuited, no current will flow in this port 2. So I2 is equal to 0. That is, I2 is equal to 0. If I make I2 is equal to 0 in the above equations, then I will write V1 is equal to AV2 and I1 is equal to CV2. From this, A is equal to V1 by V2 and C is equal to I1 by V2. It is at I2 is equal to 0. It is also at I2 is equal to 0. This A is called as voltage gain, V by V, voltage gain. That too it is reverse voltage gain. So it is named as reverse voltage gain. If it is V2 by V1, then that is forward voltage gain. Since it is V1 by V2, it is named as reverse voltage gain. with port 2 open circuited, with port 2 open circuited, with port 2 open circuited. Now this C, it is I1 by V2. I by V is nothing but admittance, and it is named as, since it is I1 by V2, it is transfer admittance. It is transfer admittance with port 2 open circuited. Now, and the units for this C are mhos, are the units for this C. Next, that means if I open port 2, I am able to calculate the values of A and C. Next, if port 1 is open circuited, if port 1 is open circuited, that is I1 is equal to 0. If it is this port 1 is open circuited, I1 is equal to 0. That means if I make I1 is equal to 0 and substitute in these expressions, then what I get here, here if port 1 is open circuited, if I make I1 is equal to 0, then I cannot find the values of B and D here. So to find this B and D, I need to make this V2 is equal to 0 here. If V2 is equal to 0, then V1 is equal to minus BI2. From that, B is equal to minus V1 by I2. I am able to calculate the values of B and D if and only if V2 is equal to 0. V2 is equal to 0 means I need to short circuit the second port. So here, if port 2 is short circuited, that is V2 is equal to 0. If port 2 is short circuited, VD is equal to 0. If I substitute this VD is equal to 0 in these equations, then I will get V1 is equal to minus BI2 and I1 is equal to minus DI2. I am able to calculate these values of B and D here, that is minus V1 divided by I2 at V2 is equal to 0 and D is equal to minus I1 by I2 at V2 is equal to 0. This V1 by I2, it is voltage by current. Voltage by current is nothing but the impedance. Since the impedance doesn't take the negative value, here this negative side and this actual I2 value will be in negative values. So this negative value will get cancelled. Finally, we will get it as positive value. Here also this negative value of this I2 will get cancelled. We will get the positive value here. So it is an impedance. That too, what impedance it is? It is transfer impedance. Because it is V1 by I2, it is transfer impedance with port 2 short circuited. Next, D, it is nothing but the gain, current gain it is. If it is I2 by I1, that is forward current gain. Since it is I1 by I2, it is a reverse current gain. With port 2 open circuited. Now the units for this B are ohms and the units for this one are, so there are no units here, no units for the current scale. Here also for A, it doesn't have any units. A and D doesn't have any units. Now let me derive the condition for reciprocity and condition for symmetricity in terms of ABCD parameters. So the condition for reciprocity. We already discussed this reciprocal. The network is said to be reciprocal if and only if the ratio of excitation at one port to the response at the other port should be same even when the even when the excitation and response are interchanged, provided one of the ports should be short circuited where the response is calculated. Now it will become short circuited here in this 2-port network. This is excitation. Now it is a short circuited. It is 1 dash, it is 2 dash, and the direction of the current is I2, and I am taking the direction of this current as I2 dash. Normally the direction of the current will flow like this. So it is a 2-port network. 2-port network. Now the ratio of excitation to the response, here the excitation is Vs, response is I2 dash, should be same even when the excitation and response are interchanged. Interchanging means, that means the same 2-port network. If we interchange this excitation, that is V2 is equal to Vs, and this current is I2, and this should be short circuited. This current is I1 and this current is I1 dash. Now here the ratio of excitation to the response here, that is Vs by I1 dash. From the theorem of reciprocity, this Vs by I2 dash should be equal to Vs by I1 dash. Now I need to calculate this Vs by I2 dash in terms of ABCD parameters, Vs by I1 dash in terms of ABCD parameters. Now what are the equations for ABCD parameters here? V1 is equal to AV2 minus BI2, and I1 is equal to CV2 minus DI2. Here this V2 should be equal to 0 because the second port is short circuited. So the conditions here are V1 is equal to Vs, I2 dash is equal to minus I2, or I2 is equal to minus I2 dash, I2 is equal to minus I2 dash, and V2 is equal to 0. If I substitute these values in the above expressions and calculate this Vs by I2 dash, now V1 is equal to Vs, so Vs is equal to, V2 value is 0, so it is 0, minus B into this I2 is equal to minus I2 dash, so it is I2 dash. Now from this Vs by I2 dash is equal to, what is this value? It is B. So let us consider this one as equation number 1. Now from here try to calculate the Vs by I1 dash value. So let us substitute V1 is equal to AV2 minus BI2, and I1 is equal to CV2 minus DI2. Here the conditions here are V2 is equal to Vs, and I1 is equal to minus I1 dash, V1 is equal to 0. Now if I substitute these values in the above expressions, V1 is equal to 0, so that 0 is equal to, or V1 is 0, A into Vs minus B into I2. So from this, is there any chance of finding this Vs by I1 dash? No. So let us substitute these conditions in this expression. I1 is equal to minus I1 dash, that is equal to C into V2. V2 value is Vs minus D into I2. What I need to find here is, I need to find the value of Vs by I1 dash. So I should convert this I2 in terms of I1 dash and IVs. So from this I can find AVs is equal to BI2. So I2 is equal to A by B into Vs. So if I substitute this I2 value in this expression, I will get minus I1 dash is equal to CVs minus D into A by B into Vs. Now if I take this Vs as a common, Vs BC minus AD divided by B. So it is minus I1 dash. Now what I need to find here is this Vs by I1 dash. So Vs by I1 dash is equal to, it is B divided by AD minus BC. If I cross multiply and multiply with negative sign, then this expression I will get. So it is equation number 2. As per the reciprocity theorem, this Vs by I2 dash is equal to Vs by I1 dash. So from the reciprocity theorem, Vs by I2 dash is equal to Vs by I1 dash. So from equation 1 and equation 2, these two should be equal. So B is equal to B divided by AD minus BC. So this B and this B will get cancelled here. So AD minus BC is equal to 1. So this is the condition for reciprocity in terms of ABCD parameters. Now let me derive the condition for symmetricity in terms of ABCD parameters. The condition for symmetricity. In terms of ABCD parameters. As per the definition of this symmetricity, the network is said to be symmetrical if the ratio of excitation and response at the same port should be equal to the ratio of excitation to the response at the other port, provided one of the ports should be open circuited. So let me derive this and let me explain clearly here. So let us consider this V1 is equal to Vs, this is I1, and this should be open circuited while we are deriving the condition for symmetricity, and this is I2, that should be 0, it is plus and minus, it is V2. It is a two-port network. Now I need to find this Vs by I1. Next, it is the ratio of excitation to the response at one port should be equal to the ratio of response to the excitation or excitation to the response at the other port, provided one of the ports should be open circuited. Now it is V2 is equal to Vs and this is I2. This should be open circuited, it is plus and minus, it is V1, and I1 should be equal to 0. Now I need to calculate Vs by I2. These two should be same for the symmetrical networks. So we try to calculate this Vs by I1 now. So use these equations. V1 is equal to AV2 minus BI2. I1 is equal to CV2 minus DI2. Now here, what are the conditions here? V1 is equal to Vs, I2 is equal to 0. If I substitute these values in the above expressions, Vs is equal to AV2 and I2 is equal to 0. From this, can I calculate this Vs by I1? No. Now substitute these values in this expression. Now it is I1 is equal to CV2. C into V2 is V2. Okay. From this, A into the value of V2 from here. V2 is equal to I1 by C. So it is I1 by C. So it is Vs. From this, Vs by I1 is equal to A by C. Let us represent it is equation number 1. Now for this expression, for this network, I am going to calculate this Vs by I2. So same expressions use here. V1 is equal to AV2 minus BI2 and I1 is equal to CV2 minus DI2. Here the conditions here are V2 is equal to Vs and I1 is equal to 0. If I substitute these values in these expressions and try to find these values of Vs by I2. Now let us substitute this value here in this expression. V1 is equal to A into Vs minus B into I2. I need to calculate this Vs by I2. So I should convert, or I should replace this V1 in terms of Vs and I2. Is there any possibility? Here I1 is equal to, so here if I substitute these values in this expression, 0 is equal to, I1 is equal to 0, C into Vs minus D into I2. From this equation itself I am able to calculate the Vs by I2. CVs is equal to dI2. So Vs by I2 is equal to D by C. Let me represent this equation as 2. From these two equations, from the condition of, from the symmetricity condition, Vs by I1 is equal to Vs by I2. Now if I use these values, A by C is equal to D by C. If I cancel these two, this A is equal to D. This is the condition for symmetrical networks in terms of ABCD parameters. Now let me solve some of the problems regarding to these transmission parameters. This is one of the problems. Obtain ABCD parameters for this network. So to obtain the ABCD parameters of the solution here. So here V1 is equal to AV2 minus BI2. I1 is equal to CV2 minus DI2. These are the expressions here. I need to calculate the values of A, B, C and D. So now to calculate these values, let us represent this network, redraw this network and apply the mesh analysis here. So this is here it is plus V1 and it is I1. It is 1 ohm, 2 ohms, 1 ohm, 2 ohms. It is I2 and it is plus or minus, it is V2. So let us consider these are the three loops are present here. This is I1 and this current is I2. You can represent this I3 like this or like this, any direction. So let I am representing this is I3. Now let me write the mesh equations for all the loops here. For loop 1, if I write the mesh equation, V1 is equal to I1 plus 2 into, this is I1, it is minus I3, I1 minus I3. Next, if I rewrite this expression, 3 into I1 minus 2I3, it is V1. So it is equation number 1. So for loop 2, now for loop 2, this one, let us consider this as loop 2. This V2 is equal to, this voltage is equal to this voltage. So the current flowing through this loop is I3 plus I2. So it is 2 into I2 plus 2 into I3. So now it is equation number 2. For loop 3, it is loop 3. So it is plus and it is minus, plus and minus, plus and minus. Now I can represent it as minus 2 into current leaving the terminal direction, minus, so it is minus 2 into, this is I3 and it is I1, both are in opposite direction. So it is I3 minus I1, it is minus 1 into I1 minus, this is minus 2 into, this is I3 and I2, both are in the same direction. So it is I3 plus I2, that is equal to 0. If I rewrite this expression, it is plus 2I1, it is minus I1, so it is I1. I2 terms minus 2I2, it is minus 2I3, minus 2I3, minus 4I3, that is equal to 0. So it is equation number 3. So all these expressions, all these equations, V1, first, second and 3. So what can I get here? I need to write these expressions like this. That means this V1 should be in terms of V2 and I2. And use this equation number 3. 4I3 is equal to I1 minus 2I2. So I3 is equal to 1 by 4, that is I1 by 4 minus 1 by 2 into I2. So let us represent this is equation number 3 or this one. So it is equation number 3. So I need to write this V1 in terms of V2 and I2. So let me represent this V1 from equation 1 or from equation 2. Can I get V2 in terms of I1? Okay, so it is I1 is equal to I2 and I3. Okay, I3 from this. Here I did a mistake. I see while I am writing the loop 3 equation, this minus 2 into I3 minus I1, this is okay. It is minus I3, it is not minus I1, it is minus I3. So if I write this, if I rewrite this expression, so it will become minus 2I3 minus I3 minus 2I3. 3 is minus 5I3 and it is plus 2I1 plus 2I1. It is minus 2I2 minus 2I2. So that is equal to 0 here. Now it is 5I3 is equal to 2I1 minus 2I2. So I3 is equal to, it is 2 by 5 into I1 minus 2 by 5 into I2. Let us represent this equation as 3. This from equation 1 and 3, from equations 1 and 3, this V1 is equal to 3 into I1, it is equation 1, minus 2 into, in place of I3 substitute this, it is 2 by 5 into I1 minus 2 by 5 into I2. If I rewrite this expression, it is 3 into I1 minus 4 by 5 into I1 plus 4 by 5 into I2. So it is 5 3 is 15, 15 minus 4 is 11 by 5 into I1 plus 4 by 5 into I2. So it is V1. And if I rewrite this expression, I need to write these expressions in this form. So I1 is equal to CV2 minus DI2. So if I write this 11 by 5 into I1, sorry, can I get it? No, I cannot get this one. So it is V1 is equal to AV2 minus BI2. So I2 is there. So I need to convert this I1 in terms of V2 and I2. So which expression is preferable to use that to convert this I1 in terms of V2 and I2. Now you see this I3, if I substitute this I3, that is third equation, in this second equation, then this will be in terms of I1, I2 and V2. So let me substitute this equation number 3 in equation number 2. So what is that equation number? Okay, let me solve here itself. So it is equation number 2 from equations 2 and 3. V2 is equal to 2I2 plus 2 into I3. I3 is this one. That is 2 by 5 into I1 minus 2 by 5 into I2. Now from this it is 2I2 plus 4 by 5 into I1 minus 4 by 5 into I2. So 4 by 5 into I1, it is 5 2s 10, 10 minus 4 6, 6 by 5 into I2. So it is V2. Now I can write this expression like this: 4 by 5 into I1 is equal to V2 plus 6 by 5 into I2. So I1 is equal to 5 by 4 into V2 plus 5 by 4 into 6 by 5 into I2. This 5 and this 5 will get cancelled. 2 2s, 2 3s here. So what I get here, 5 by 4 into V2 plus 3 by 2 into I2. So this is I1. So from this, I1 is equal to this 5 by 4 into V2 minus, sorry, it is plus 3 by 2 into I2. Here it is not minus 6 by 5, it is plus 6 by 5. Why? Because it is 4 by 5 into I1, it is also I2, I2. If I take I2 as a common here, 5 2 is 10, 10 minus 4 is plus 6. So it is plus 6 into so now if I bring this term to the left side, then it will become V2 minus 6 by 5. So it is V2 minus 3 by 2. So it is V2 minus 3 by 2. So finally, so let us consider this is equation number 4. Equation number 4. So it is like I1 is equal to CV2 minus DI2. So the value of C here is 5 by 4. D value here is minus 3 by 2. Next, I need to write this expression here. V1 is equal to AV2 minus BI2. So I already write here. This is let me consider this equation as let us represent it is 4 and it is 5. It is equation number 5. So from this equation number 4 and this equation number 5, if I am able to write this expression in this form, V1 is equal to AV2 minus BI2, that means V1 should be in terms of V2 and I2. Here I2 is there already. I need to convert this I1 in terms of V2 and I2. So use this expression 5 to convert this equation number 4 in terms of V2 and I2. So now from equations 4 and 5, so V1 is equal to 11 by 5 into, in place of I1, 11 by 5 into I1, in place of I1 write this one, 5 by 4 into V2 minus 3 by 2 into I2 plus 4 by 5 into I2. So this 5 and this 5 will get cancelled here, so it is 11 by 4 into V2 minus, it is 11 is 33 divided by 5 2 is 10 into I2 plus 4 by 5 into, so if I multiply with 2 here, it is I2. So what will happen here, 11 by 4 into V2, it is 8 divided by 10. So if I take I2 as a common here, plus I2 into, so 8 divided by 10 minus 33 divided by 10. So it is equal to 11 by 4 into V2 plus I2 into, so it is 30 minus 8, it is 22 plus 3, that is 25. So it is minus 25 divided by 10, I think so it is. So V1 is equal to, this expression I can write as so it is 5 5 5 2 6, this one. So it is 11 by 4 into V2 minus 5 by 2 into I2. So this is V1. So this is equation number 6. And let us compare this equation number 6 with V1 is equal to AV2 minus BI2. So the values of A here is 11 by 4 and B here is minus 5 by 2. Right? Sorry, B here is plus 5 by 2. The B value is, it is an impedance normally, it should not be negative values. So B from this is 5 by 2. And from this C is equal to 5 by 4 and D is equal to 3 by 2. So if I write this ABCD matrix or transmission parameters, so A value here is, it is 11 by 4, B value here is 5 by 2, C value is 5 by 4, is 5 by 4, D value here is 3 by 2. So this is how we need to solve for this type of problems. Okay. Now another problem. Here another problem I'm going to solve here. So this is the another problem in transmission parameters. So for this, so I need to write the expressions or equations for this network like this. V1 is equal to, in this form, AV2 minus BI2 and I1 is equal to CV2 minus DI2. So Here for this network, draw this network here. This is S and this is 1 by S. This is plus and minus, it is V2. This is I2. This is 1 ohm S here. So it is this one, it is plus and minus V1, so I1. So the voltage across this one is V1. The voltage across this one is V2. So it is first node and second node. So this voltage is V1 and this voltage is V2. Now if I use the nodal analysis, that is I1 is equal to this current plus this current. So I1 is equal to this current is this voltage divided by the impedance. Voltage is V1 divided by the impedance is S, plus this current is potential difference across this one, that is V1 minus V2 divided by the impedance or the resistance, that is 1. So this is I can write this expression as V1, if I take V1 as common, 1 by S plus 1 minus V2. If I write this one as S plus 1 divided by S into V1 minus V2. So I1 is equal to this one. I1 is equal to S plus 1 divided by S into V1 minus V2. That is considered, it is equation number 1. Next, if I write the nodal equation at node, so at node 1, it is at node 1. So now at node 2, so this I2, this current is equal to this current plus this current. This current is I2, that is equal to this current. So the voltage divided by the impedance, that is V2 divided by impedance is 1 by S, plus this current is potential difference V2 minus V1 divided by this one. So this is 1. So I can write this one as V2 into S plus V2 minus V1. So if I take this one V2, if I take V2 as common, it is S plus 1 minus V1. This is I2. But it should be here I1 is equal to, so this form, I should take these expressions in this form. So I1 is equal to this AV2 minus BI2. So I need to write this V1 in terms of V2 and I2. So for that I am using this expression here. So V1 is equal to I2, sorry, it is V1 is equal to V2 into 1 plus S, this one, if I bring this term to is minus I2. So let us consider this one as, so from this it is equation number 2. Now substitute this V1 in this first equation. That means from equations 1 and 2. So I1 is equal to S plus 1 divided by S into V1 is this one, V2 into 1 plus S minus I2. So it is what is that, this V1 is this one minus V2. So now it is if I calculate it, V2 into 1 plus S whole square divided by S minus 1 plus S divided by S into I2 minus V2. So if I write this, expression here, if I take V2 as a common here, V2 into this 1 plus S whole square by S minus 1 plus S divided by S into I2. So here if I take common here, V2 into 1 plus S square plus 2S minus S divided by S minus 1 plus S divided by S into I2. So it is I1, that is equal to this V2 into this S square plus S plus 1 divided by S minus 1 plus S divided by S into I2. So it is this one. So let us represent this is equation number 3. So it is in the form of I1 is equal to CV2 minus DI2. From this C value is S square plus S plus 1 divided by S, and D value here is 1 plus s divided by s. Now I need to find the values of a and b here. For that I need to use this expression. V1 is equal to, from this itself I can calculate the value of a. So it is V1 is equal to AV2 minus BI2. So the value of a from here is a is equal to 1 plus s and b is equal to 1 here. So I know the value of a, b and c, d. So let us represent this a, b, c, d parameters here. A, b, c, d values, that is equal to, a, b, c, d is equal to, a value here is, it is s plus 1 and b value here is 1 and c value here is s square plus s plus 1 divided by s. So s square plus s plus 1 divided by s, and d value here is 1 plus s divided by s. So it is 1 plus s divided by s here. So this is how we need to solve these transmission parameters.